Omniolytics team, also known as the Chicken Group from our colleagues. And so these are my team members, Makakole, Skumbuzo, and Siriso. Um, so just some objectives that the client has is that in future, right now and in the future, what he'd like to do with this project and this product is to be able to reduce bird mortality and improve the growth rates of the chickens, and then also facilitate early threat detection, which is just basically a prevention for what happened last year with the influenza, which led to a 900 million national loss, and just improve logistics. And all of these will be across the poultry value chain. So before I begin, I just want to briefly go through the poultry farming process. So essentially, hatchlings come in from a hatchery and they get to the farm and they are split then into the broiler houses. And so because we're investigating a specific farm, our farm has 10 broiler houses. And so the chickens come in and they are put into these broiler houses that are meant to be under certain conditions. And these conditions are set out in a best practices file. And that's basically just the industry standard of what the conditions should be within the broiler house and the activities that should take place. So for example, that would be things like the pH level in the water, the luminosity of the lights, how long the lighting is on, when the chickens are fed or vaccinated. So bearing this in mind, the client approached us and was like, guys, please generate some insights using this data and try and find out what is either killing these chickens or making them fat. And then what he also wanted us to try and do is make a comparison between some best practices and observed practices. So remember I said the best practices is the industry standard, and the observed practices was basically the client took him to the farm and said, listen, go and check what they're doing, observe all the activities that's taking place, are they meeting up with the best practices, and then come back with that information. So we had that information, and then also he wanted us to kind of build a model that can be used across poultry farms. So bearing this in mind, as the team, we looked at the data and we realized that the data is not really appropriate for what we were trying to do. And by appropriate, I just mean that for us to be able to conclusively say something like the chickens are dying because of the pH level, we needed better data, more informative data. And by that, I just mean that if we have the chickens are dying at 43 a day, we also needed information like what was the sensor readings for that day. So what was the pH, what was the air temperature, and what were the activities that were being done? Like, was the lights being kept on when they were supposed to, were they put off when they were supposed to, things like that. So this is actually an example. These two screenshots are examples of the data that we did have. And so here the rows is the days of a 34-day cycle. And we had 11 cycles. And in each of those cycles, we had 10 houses. And so that's the information that came through the mortality, the chicken mortalities. And then we also had information about the air quality and the water quality. So here for the water quality, we can see we have information like electrical conductivity, oxygen reduction potential, and pH. And for the air quality, we had ammonia, carbon dioxide, relative humidity, and something else. So we met with the client, we put our thinking hats on, and we thought to ourselves, what can we do with this data that's going to be valuable to the client? So we built a web app and we did some analysis. And so now I will hand over to Makakole to go through the workings of the web app.
Good day, everyone. I'll just briefly explain how the web app functions. As Nadine mentioned earlier, the problem that we had with building something that the client would use was with the data that we had. The data wasn't thoroughly captured, and the data wasn't. Some of the data was corrupt. So we thought, moving forward for future data analysis, we should provide our client with a tool that will enable him to capture data thoroughly and also store data thoroughly. So we came up with an app, a web app, which can be accessed across a multiple number of devices, which suppose on a specific day at a specific cycle at a specific house on the farm, a worker could go in, or even the farmer himself could go in and track the activities that they're supposed to do for that day. So this is like different activities for each specific day, and then they would check them on the checklist, and then compare the ones which have been done and the ones which have not been done, and also make analysis on the current activities on the farm, and also be able to track what's happening with environmental conditions and within the houses. So this will also help in future when there's a specific problem that's associated with the chickens, and then they could just go and check on a specific day was a specific task done, and how is it impacting the mortality and the physical weight of the chicken. So I'll now hand over to Skumbuzo.
So, good day everyone. As Nadine and Makakule have already mentioned, that the data that we have didn't actually allow us to dig in more and get some more insights from the data. So what we decided to do, in addition to the web application, so what we did, we visualized we took the data, did some cleanup, and then we visualized the data, and then we looked at the best practice files, the recommended standards, and then we tried like to include some different range hold to say like maybe the temperature is okay when it is at this level. So, and then we try to calculate it, or whenever it deviated from what is actually the standard one. So we have like graphs. Here I have an example. This example actually shows the pH reading from the sensor, and also the different range holds. So if it is like less than 5%, and then if it is less than 5, then it means like there's something wrong, and if it is above 6.5, it means like there's something wrong. So we calculated this percentage for all the different matrices, such as the temperature, all of them, just that we do not have enough space to put them all there. And so in addition to that, we try to explore some possibilities that can be done whenever, say we had like the data structured in a manner that can allow us to do. So we could look at like different correlations between the different matrices, and maybe at some point just okay, maybe at some point we could just find relationship between the different matrices, maybe to say they influence maybe the death of the chickens, and also the mortality rate. And I also have an example here that maybe we can also have like a relationship which can compare the mortality with the temperature or the different attributes. And in addition to that, we also were not able like to implement like a working model because of the data. Actually, the problem was that the data, they collected sensor data and the mortality data, they actually did not overlap. So one was taken at a different time and the other was taken at a different time. So we could not say like maybe we can include both of those and use them for modeling. But then here we're just saying that maybe if looking at like the best case scenario, we can actually develop models to actually model different the relationship between the different house conditions as well as the mortality of the chickens. So yeah, I think that's it.
Okay, and then going forward for the next phase probably of this project, we're suggesting that the client stores and structures the data in a manner that is efficient and effective for predictive analysis, because essentially that's what the client would have wanted, but due to certain constraints we weren't able to. and then also have the kind of the data coming in at the same time. So if we're looking at mortality, we need to have activities that were either completed or not completed for that mortality, as well as the sensors. And then we're also suggesting processes for backing up data in the aid of losing data or file corruption. Thank you. Hi, my name is Nadine, and I was working with the Omniolytics project and at CSIR in the DSI program, and what we produced was viable products for our client who is trying to optimize chicken farming.